Good morning, students. Today we are starting class 12th mathematics first lesson, relations and functions. Relations. The concept of term relation in mathematics has been drawn from the meaning of relation in English language, that means connection or link between two objects or quantities. Let's some example of relations. First of all, we'll discuss about some sets. Let take one set A where X such that X is a student of class 12th in RPS, and another set B Y such that Y is a student of class 11th. Examples of relation from A to B. What these sets A and B have relation, what kind of relations they can have, we'll see here in these examples. First, AB belong to A cross B such that A is brother of B. Here, is brother of is a relation between A and B. Now, take some another example. Second example, AB belong to A cross B such that A is a sister of B. Here, is sister of is relation between A and B. AB belong to A cross B. A and B live in same locality. This is the relation between A and B. Now another term which you must know, that is relation in a set A, it means subset of A cross A. Just remember this. Now we'll discuss about types of relations. First, empty relation. A relation R in a set A is called empty relation if no element of A is related to any element of A. It means R equal to phi subset of A cross A. Now another relation, universal relation. A relation R in set A is called universal relation if each element of A is related to every element of A. It means R is equal to A cross A. Now another very important relation we are discussing now, equivalence relation, equivalence relation. A relation R in a set A is called equivalence relation if it will follow these properties. Now first of all, relations must be reflexive. Reflexive if A comma A belong to R. For every A belong to A, it means each element of A will relate with itself. Then we say the relation is reflexive. B. Symmetric. If A comma B belong to R, this implies that reciprocal of it means B comma A will also belong to R. For every AB belong to A, then we will say that relation is symmetric. Now third, transitive. If AB belong to R and BC belong to R, and then AC belong to R, for every ABC belong to A, it means first and third element is also related with the relation or following the relation, then we will say that this is transitive relation. Now again remember this, if a relation R in A said to be an equivalence relation if R is reflexive, symmetric and transitive also. Now we will understand these concepts by some examples. Example 1. Let T be the set of all triangles in a plane with R a relation in T given by R equal to T1, T2 where T1 congruent to T2. show that R is an equivalence relation. Solution. Reflexivity. R is reflexive as every triangle is congruent to itself. It means T1, T1 will definitely belong to R as T1 congruent to T1, as we know that each triangle will be congruent to itself. Symmetric. R is symmetric since T1, T2 belong to R implies that T1 congruent to T2. This implies that T2 congruent T1. As you can see here, I reversed the value T1 T2. I am writing it T2 T1. So according to mathematics, this will be correct statement. This implies that T2 T1 belong to R. So this shows this relation is symmetric also. Now we'll see transitivity. R is transitive since T1, T2 belong to R, question number 1, and T2, T3 belong to R. From 1 we can see T1 congruent to T2, and from 2 T2 congruent to T3 as given in the question. Here we can see that T1 is also congruent to T3. This implies that T1, T3 will belong to R. Therefore, R is an equivalence relation as it is having all the properties reflexive, symmetric, and transitivity. Let's take one more example. Let L be the set of all lines in the plane and R be the relation in L defined as R equal to L1 L2 such that L1 is perpendicular to L2. Show that R is symmetric but neither reflexive nor transitive. Now see the solution. A. Reflexive. R is not reflexive as line L1 cannot be perpendicular to itself. It means L1, L2 will not belong to R. Symmetric. B. Symmetric. R is symmetric as L1, L2 belong to R implies that L1 perpendicular L2 implies that L2 perpendicular L1. If a line is perpendicular to another line, obviously the another line will also perpendicular to similar line, same line. This implies that L2, L1 will belong to R. Transitive. R is not transitive as L1, L2 belong to R implies that L1 perpendicular L2, L2, L3 belong to R implies that L2 perpendicular L3. This implies that L1, the first line, L3, the third line, is not perpendicular. In fact, they are parallel to each other. So this implies that L1, L3 will not belong to R. Suppose this is L1 and this is another line L2 and another line L3. These lines are perpendicular, these lines are perpendicular, so L1 line will be parallel to L3. Similarly, if we see the symmetricity, if L1 is perpendicular to L2, so they both are making 90-degree angle with each other, so no issue at all. Now if we see the reflexive part, if L1, suppose this line is L1 and this line, if I'll make this line again here L1, these lines are not perpendicular, these are parallel lines. So this is also not true. So L1 will not be the part of R. So it is not reflexive. Thank you.